So let's start off with a warm-up problem where we're finding the factors of a number here. So we're given 20 and we have to find all its factors. So I'm going to start from the lowest number to the highest factor. So when I'm thinking about factors, I'm thinking about what number divides into that number. So I know 1 always divides into anything, so 1 always works, so 1's a factor. 2 will divide into 20. 3 doesn't, but 4 does. 5 also divides into 20 because 4 times 5 is 20. 6 does not divide into 20, neither does 8, 9, but 10 does. And then after that, I think it's just 20 left. 20 divides into 20. So these are all the factors of 20, and if you don't believe me, go through the list again from 1 through 20, and you'll realize these are the only numbers. And also, I want to mention a cool trick here. So I learned this in middle school. If you look at your numbers, if they're in order, if you multiply the ends with each other, you can make a rainbow, or you should be able to make a rainbow. So 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. And there you go, you have a little rainbow. But I thought that would be a nice helpful trick in case you are checking to see what are your factors. So you should be able to make a pairing of each product to get the factor or to get the values. This one here is a 9, so I know 1 will work. 1 always works, so I always start with 1. 2 doesn't work. 3 does divide into 9. And then 6 doesn't work, 7 doesn't work, 8 doesn't work, but 9 does. So again, 1 times 9 is 9, and then 3 times 3 gives you 9. So these are the 3 factors for 9. So listing out factors is going to really help us when it comes to finding all the real possible zeros or all the real possible solutions for a polynomial. So there's a formula. And it looks really, intimidating, but it's actually a very simple formula. So basically, if you want to find all the real possible solutions, what you do is take the factors of the constant. So when we're thinking about the constant, it's always like the number that doesn't have x. So in this case, 10 here is the constant. Let me use a highlighter here. Yeah, there we go. So 10 is our constant. Let me label that. So we always take our constant, the n number, and then we take our leading coefficient. So in this case, 5 is our leading coefficient. I'll just call LC. So you take your constant, you're going to find all the factors of your constant, and then list them out. And then you're going to find all the factors of your leading coefficient, and that's going to be in the denominator. And then there should always be a plus and minus in front. So this will allow you to find or make a list to help you find all the real possible zeros that would be for this polynomial. And I'll show you why that's important. But let's go ahead and see if we can list them out. So I'm going to do plus and minus first because there's a plus and minus in this formula. The factors of 10, let's think about it for a moment. So factors of 10 is 1, 2, 3 doesn't work, 4 doesn't work, but 5 does. And then we would have 10. So 1 times 10 is 10, 2 times 5 is 10. So those are all the factors of 10. And then I need to find factors of the leading coefficient for the denominator. So factors of 5, 5 is a prime number, so only 1 and 5 would work. And so what you're going to do with your list of numbers here is you're going to always take the denominator. I recommend using the denominator because you have fewer numbers. Take your denominator and divide all the top by that first denominator. So I'm going to take 1, and I'm going to take the top and divide it by 1. And then each value is going to have a plus and minus. So 1 divided by 1 is 1. 2 divided by 1 is plus and minus 2. 5 divided by 1 is plus and minus 1. So you can see I'm taking the top and dividing it by my first digit in the bottom, which is a 1. 10 divided by 1 is a 10. And I'm going to put a plus and minus. So basically, if I divide all the top with 1s, it's just going to be itself with a plus and minus sign. So basically it says that my zero or my solution could be a positive or negative 1 or positive or negative 2 and so forth. Now that I'm done dividing by 1, I'm going to divide by 5. But here's the thing, you don't want to have repeats. So if you already have a 1, you don't want to rewrite a 1. So let's see what we would get. So we're going to take 1 and we're going to divide it by 5. So we're going through the list again, but we're dividing by 5 now. So this is going to be plus and minus 1/5. So I'm going to write it as a fraction, and it's okay to have a fraction. 2 divided by 5 is going to be 2/5. But notice I'm putting the plus and minus in front. 5 divided by 5 is a 1, but I already have a 1, so I don't need it. 10 divided by 5 is a 2, and I already have a 2, so I don't need it. So these are all my possible list. So what this really allows us to do, or this formula here that allows us to make this list of possible zeros, is essentially what we're doing is finding what x could be as a solution. Now, it doesn't guarantee that, any of these are a possible solution. What it does is it closes in on where the solution could be. It might not be exactly 5, but it might be close to 5. Or it might not be exactly 10, but it could be close to 10. And what this allows us to do is to not always look at a graph for, strenuous, because graphs can go from negative infinity to positive infinity for x's. And so this helps narrow down our search for what x could be. And it becomes extremely helpful when we're finding solutions. So let's practice this skill before we use it to find solutions. So again, using this formula up here, what we're doing is we're finding the factors for the constant, so the last number, and finding the factors of the leading coefficient, which is usually the first number. So the constant is always the number that is by itself, usually at the end. So right here is my constant. So I'm going to find its factors, and then my leading coefficient here is 1 because my highest power is x to the third. So my leading coefficient is the number in front of it, which is 1. So if I start with my formula, I got to have a plus and minus. And so you always have the factors of the constant on top. So factors of 8 are 1, 2 divides into 8, 4 divides into 8, and 8 divides into 8. So those are all the factors, because 2 times 4, 1 times 8 gives us 8. And then the bottom is just a 1 because we're just finding factors of 1, which is just going to be 1. And so this one will be easy. I'm just going to take all of these numbers and divide it by 1. So we'll have plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. So if I take all of these numbers and divide by 1, I would just get itself. So 2 divided by 1, 2, 4 divided by 1, 4, 8 divided by 1, 8. And those are all the possible factors. So that allows me to, if I were to graph it, I might be searching for numbers that are close to 1, 2, 4, or 8, whether that be on the negative side of the x-axis or the positive side of the x-axis. All right, for B here, it looks like my constant is a negative 1, and then my leading coefficient is a 2. So got to use my plus and minus. Factors of 1 is just 1. And don't worry about that negative sign either, because you're just finding factors of that value. So in this case, factors of 1 is just 1. Factors of 2, you have 1 and 2, right? 1 divides into 2, and 2 also divides into 2. So it looks like you have 1 divided by 1, which is plus and minus 1. And then 1 divided by 2 is plus and minus 1/2. And that's all that you have. So this here doesn't have very many factors to work with. Your x could be somewhere between 1 or 1/2, either in the negative x values or the positive x values. All right, last but not least, this one is a bigger constant here. Constant here is a 30, and then your leading coefficient here is a 2. That's in front of x cubed. So got to use a plus and minus. So let's think of factors of 30. So I know 1 will work, and then 2 works because 2 times 15. 3 definitely works because 3 times 10. 4 does not work, but 5 does. So 6 has to as well. So 5 times 6 is 30. 3 times 15 is going to give me, or sorry, not 3 times 15. What am I thinking of? 3 times 10 gives me 30. 2 times 15 gives me 30. And then 1 times 30 is 30. So those are all the factors for 30. And then factors of 2 are 1 and 2. And here we go. There's going to be quite a list here. So first, let me divide everything by 1, because that would just be itself. So 1 divided by 1 is 1. 2 divided by 1 is 2. So plus and minus 1, plus and minus 2, plus and minus 3. So I'm just dividing by 1 first. Plus and minus 6, plus and minus 10, plus and minus 15, plus and minus 30. Now that I'm done dividing by 1, I'm going to divide by 2. So remember, we don't want to write repeats. If we have repeats, we're just going to ignore them. So 1 divided by 2 is 1/2, so plus and minus 1/2. 2 divided by 2 is 1, but I already have 1, so I'm not going to write that. 3 divided by 2 is 3/2, or 1.5. And then if we take 5 and divide by 2, we get 5/2, or 5/2. 6 divided by 2 is 3, which I already have. 5 divided by 2 is 5, which I already have. 15 divided by 2, I don't have that, so plus and minus 15/2. 30 divided by 2 is, that's going to be 15, so I already have 15 here, so I don't want to repeat that. And so this is my final list of possible solutions, so definitely a larger list. That makes sense because my numbers are quite large, and so there could be quite a bit of different combinations that could happen for my solution. All right, in the next video, we'll look at how to solve polynomials using our list and then looking at graphs.